start with an overview of why this project is important, where it's placed in the research. And then I'll go through my methodology. So I'll go through how I actually got the content from the forums and how I created the corpus. And then I'll talk about the two tasks, which were topic modeling and then a hybrid machine learning methodology for emotion prediction. And then I'll just go through, I'll discuss my results at each stage, and then I'll go through what I've learned from this project. So the quote on this slide, it's very wrong that in the 21st century, there is still no specific provision for LGBT people with cancer. This is a paraphrased extract from the corpus I collected, but it kind of just summarizes why this research is important and why I embarked on this project. So current research points to the fact that there are knowledge gaps in institutional practices towards lesbian, gay, bisexual, transgender and queer questioning patients, and that the LGBTQ plus community represent a growing and medically underserved population. In a survey that was conducted, worryingly, only 53% of oncologists included in the survey said that they were confident in their knowledge of the health needs of patients in the LGBTQ plus community. So that gives some quite fundamental background to why this type of research is important. So the factors that might affect LGBTQ plus patients through their healthcare journey is choosing when to disclose their sexual orientation or gender identity to their healthcare provider, a fear of mistreatment from healthcare providers, or a lack of access to relevant information, which primarily serve a heterosexual and cisgender patient group. So why is natural language processing relevant here? Well, the existing studies of LGBTQ plus cancer patients mainly use quantitative data, and they highlight the disparities in cancer outcomes for subgroups from the LGBTQ plus community and their heterosexual and cisgender counterparts. But there's actually a lack of qualitative data which demonstrates where LGBTQ plus service users feel that care provision is inadequate. So we need more research to understand the lived experience from the perspective of LGBTQ plus people who have accessed cancer treatment. Which led me to my research questions. So in order to understand more about specific experiences, I wanted to look at how emotions are kind of portrayed on an LGBTQ plus forum. And also I tried to build an emotion prediction classifier. And so these are the three questions, which were, can a hybrid machine learning method be used to predict emotions on a small domain-specific corpus? Which emotions are relevant to the study of emotion on an LGBTQ plus cancer forum? And can topic modeling be used together with emotion annotations to provide insight into this under-researched area of medical care? So I'll go through my process for corpus creation. I'm not sure if most people listening are from a health or a corpus background. So apologies if I go too fast or too slow. So the data from the corpus was scraped from the forum that I decided to use using Selenium, which is a web driver which I used with Python. Basically automates a web page, so you can analyze the web page and find out which bits of information you need to download, and then use Python to extract this information. So this was done, I used the web inspector on the web page, found the elements that I needed to download, and then scraped them all into a data frame. It was my first time doing this, so there was a lot of trial and a lot of errors, and it was a painful process. I'm not sure if it was user error or the way that the web page was set up. It was quite difficult to find how to extract the relevant bits of information. So the information that I decided to download was the main body of the post. I also decided to download all of the posts and all of the replies. So I basically saved a data frame which had labels for the type of post, whether it was a main post or whether it was a reply. the author of the post, which was the username that the user provided and which was later anonymized, the date the post was written, the main body of the post, and the ID of the post generated by the web page, and the name of the post as named by the author. So I then split all of the posts into single sentences, but retaining the metadata for each sentence. So in total, I had 4,676 sentences in the corpus. I anonymized any mention to usernames in the corpus and any mention to places. I did try doing that with an automated method. So I tried doing it with named entity recognition, but it didn't work very well, mainly because the usernames were kind of like, as you would expect, not like recognizable elements. And the data was quite noisy. So I ended up doing that manually, which took a while, but because the corpus wasn't big, it was doable. But obviously on a large corpus, that would probably be a bit of a problem. So the next stage was to annotate the corpus. So I annotated each sentence with an emotion class. This was used in both of the tasks for emotion detection and topic modeling, but each task used a different subset of the emotion classes. So there were 8 emotion classes that I used in total. The full set was used in conjunction with the topic modeling task, but I only used a subset of these for the emotion prediction task, because for the emotion prediction classifier, I needed to use effective lexicons. And most effective lexicons that have been built have been based on Ekman's basic emotions or Plutchik's basic emotions. So I had to narrow down the emotion classes that I used for that task. So I used 4 of Ekman's basic emotions, which were anger, fear, happiness, and sadness. I used 2 additional emotions which came from the Macmillan webpage, which were shock and loneliness and isolation. Those were emotions that they state are relevant to cancer patients. And then through exploratory data analysis, I decided to use the emotions of anxiety / depression and hope as well, because they seem quite dominant in the corpus. And in this context, anxiety and depression, although they are very separate conditions, they were considered as one because it was to represent a kind of a feeling greater than the sadness, which couldn't be explained by the emotion class of sadness alone. And it's not to represent a clinical diagnosis, but just a representation of what is said in the text. There were some limitations with using this many emotion classes. The main one is that because I could only use a subset of the classes for the emotion prediction task, that limited my corpus to just over 1,500 sentences, which is a very small corpus to build and train a classifier on. But I'll talk more about those limitations later. So I conducted the annotation through, so I did one set of the annotations for each sentence, and then each sentence was also annotated by another annotator, which came through Amazon's MTurk, which was a bit difficult to use, and each sentence was actually seen by, not necessarily seen by the same second annotator. So there was a bit of variability in annotations. So I got an overall Cohen's kappa of 0.41, which shows moderate agreement between the 2 annotators, which isn't a bad score necessarily, but it isn't a good score. It's not unusual to get a score like that due to the subjective nature of emotions. It would have been better to have 3 annotators so that there was a tie-break score. And if you look at the chart on the right, you can see that for normalized inter-annotator agreement, there is a faint diagonal, which is what you would hope for, but obviously it is quite faint. And analysis of the annotation showed that most of the disagreements, most of the category pairwise disagreement were for similar classes. So where one annotator annotated a sentence with happiness and another with hope. So it was, they were logical kind of errors, I guess. So this slide just shows the breakdown of the gold standard corpus that I used. So it was quite surprising to me that actually the highest emotion annotated throughout the corpus was for happiness, and the two lowest emotions were for fear and shock. So yeah, I was expecting to see different results for that, but again, that could be caused because I've got so many emotion classes. If you kind of combine the similar classes, the results might look quite different. So this goes on to talk about how I used this corpus for the topic modelling task. So for this, I used LDA. I've never had to pronounce this before. So it's either latent Dirichlet or latent Dirichlet, depending on which YouTube video you look at. But it's basically a method that considers each document as a collection of topics in a certain proportion, and each topic is a collection of keywords, again, in a certain proportion. So the aim of this was to discover the abstract topics that are contained within the corpus. And then topic names are manually assigned based on analysis of the keyword groups that the model presents. So this slide represents my pipeline. So initially there were some pre-processing steps, which included tokenization, stop word removal, lemmatization, and I used bigrams for this. Then I used ID to word to generate a dictionary of terms, which was used against the corpus of lemmatized text to build the document frequency, term document frequency for the dataset, which basically shows how many times a word occurs in the corpus and each post to calculate the key topics, and then the likelihood of a document belonging to a topic. I used a dictionary with a mallet LDA wrapper in GenSim to perform the topic modelling, and used the coherence score to measure the quality of the topics. So I used the coherence score to decide at which point to cut off the topics. And some of the literature suggests that it's best to choose the number of topics that marks the end of a period of rapid growth and coherence score. So if you can see, I chose to cut it off at 8 topics. And then just to check that my topics were probably okay, I used a visual representation of the topics in PyLDA viz. And that's what's shown in this middle chart. And you can see that the topics are fairly evenly distributed. So they're in different areas of the feature space. There's a few topics on the left that are clustered together. But overall, it looks like my topics would be quite clearly defined. And then this slide shows the 8 topics with the names that I manually assigned to them. So if you look at the names of the topics, you can see that there are similar themes that run across the topics, which isn't unusual considering, well, one, the size of the corpus was small, but also the domain itself was one quite specific topic of an LGBTQ plus cancer forum. So it's not unusual that there's some overlap between the topics. Engaging with the community was the most dominant topic, which is logical considering that it's a community forum. And some of the other topics provide interesting areas for further research, specifically the topic of diagnosis, treatment, and sexuality. So what does topic modelling show us overall? Well, overall, there was a fairly even distribution of emotions across the topics. So for each topic, roughly, there was a 50-50 split of positive and negative emotions. My initial assumption was that there would be some topics that were more highly correlated with some emotions than others, but it doesn't look like it's the case. But the topics do demonstrate why people come to the forum, and the topics are useful in pointing us to important data and just provides an automated way to see how text within a corpus can be grouped to establish themes across the corpus. This table shows an extract of paraphrased sentences that were taken from the corpus. So I've split them into the emotions, and they kind of show quite clearly how users of the forum feel in relation to this topic. There are a mix of emotions, including shock that discriminatory behaviour still exists in a healthcare provision, and also isolation from a lack of support for LGBTQ+ populations. So the data provides evidence to suggest that the emotion classes of loneliness and isolation and anxiety and depression are relevant to research in cancer forums, because the sentiments of these posts go beyond sadness and express a more complicated set of emotions. The extracts also provide further evidence for the suggestions made in existing research, exemplifying that there's a lack of access to relevant materials and there is a fear of mistreatment and a fear of disclosing sexuality to health providers. So if I just go through, these are the specific posts that kind of provide evidence to the existing research. But there's also positive feedback from the forum. So users describe positive experiences that they've had with healthcare providers, and also describe the benefit of having access to a forum and community support. And this post specifically, but also other posts that I found through my analysis, do describe suggestions for how the situation could be improved. One of the clear themes that came from that was that more training is needed for medical healthcare providers in treating underrepresented groups. So now moving on to my second task, which was the hybrid methodology for emotion prediction. This slide basically shows the architecture for my classifier. It's a hybrid methodology because it combines keyword spotting and the use of an effective lexicon with machine learning. The emotion prediction pipeline uses the reduced set of emotion classes, so the 4 of Ekman's emotions that were described earlier, and the corpus size of 1,575 sentences. Just to provide some background on machine learning classifiers in case anyone's not clear, supervised models require a data set which has been labelled, which is why I conducted the annotation stage. Then a part of the data set is used to train and build the model, and the held out part of the set is used to test the model and make predictions, which are compared to the true labels to assess the accuracy of the model. So depending on the type of classifier, the input to train the model can be the text from the corpus alone, or it can be the text and a set of features, or it can be just features that are derived from the text. And in this model, I use both the corpus, so the text from the corpus, and also a set of features, which I derived from the corpus. So this shows, so that the chart on the right it just demonstrates that there are a number of iterations of features that I tested the classifier with. But the main part of the emotion prediction classifier involves feature engineering, so deciding which features are most informative for the predictions. The highest scoring set of features is shown in bold on the chart, and that's the set of features that I used in the classifier. So the first set of features come from a term frequency inverse document frequency matrix, or TF-IDF. So this was built based on the STEM corpus, and it uses unigrams and bigrams. It only uses words that appear in less than 90% of the corpus, and words have to appear 5 times in the corpus to be included in the matrix. So TF-IDF is basically a statistical measure that evaluates how relevant a word is to a document in a collection of documents. The second set of features were generated using the NRC emotional intensity lexicon, which is used to calculate a score for each of the 4 emotions for each sentence. So this was calculated by iterating through each sentence in the data frame and matching any effective words to the emotion intensity lexicon. So then the score of any effective words in each sentence were summed together to give a score per emotion per sentence. Sentence polarity amplifiers and diminishers were accounted for within the context of the emotion word and the 3 preceding words. So if negation was found, the polarity of the sentence was reversed. If there was a diminisher, the score was halved, and for amplifiers, the score was doubled. And the third set of features was the number of positive and negative words in each sentence. And this was calculated using the NRC word emotion association lexicon, which is better known as EMOLEX. And it just iterated through each post and added to account the number of positive and negative words in each sentence. And then finally, in the fourth step, a valence score was calculated for each sentence, which was used as a feature. So that was just calculated using TextBlob. And to provide some background to the emotion lexicons, the NRC, the word emotion association lexicon is still the largest word emotion lexicon. And it basically provides a 0 or 1 value for Plutchik's 8 basic emotions. And it also has the list of positive and negative sentiment words as well. The emotion intensity lexicon is a more recent lexicon. I believe it was released last year, and it uses a weighted score for each effective word for 8 basic emotions in the lexicon. So, for example, in the sadness lexicon, tragic has a score of 0.961 and sad has an intensity score of 0.844. So it just gives slightly more accurate readings as to the effective words in the sentences. And this is the brief description of the overall pipeline. So the table on the right demonstrates the breakdown of the corpus into the class sizes. So it's clear to see that the corpus is very imbalanced. So the annotations for joy or happiness form nearly 50% of the corpus, whereas for fear, this contributes only 5% of the corpus. So for this reason, I needed to train my model in an imbalanced learn pipeline. So I used the smotatomic resampling method to attempt to balance these classes. So after the various pre-processing steps were conducted, depending on which features were used, I then used all of the features, I combined them together in a feature union pipeline, and then used smotatomic to resample it as I trained the model. So what that basically aims to do, it creates synthetic data points for the minority class in the training set, and then Tomic links remove near neighbors in the feature space that have different classes. So that the aim of it is to make the data less noisy so the predictions are more accurate. So I tested this with 4 different classifiers, XGBoost, random forest logistic regression, and SVM. And when I did it on just the 80-20 train test split that's shown in the table on the right, I got a result of 69% micro F1 with XGBoost. So that was actually the best score that I achieved overall. But I then used 5-fold stratified cross validation to just check that my results were replicable. And these are the results from doing that. So the table on the left shows the corpus of 1,575 sentences. We can see that XGBoost and logistic regression achieved the highest scores with the cross validation. So they both achieved 65% micro F1. I wanted to see what would happen if I had a balanced corpus, so not having to use a resampling method. So to do that, I reduced the size of the corpus and used 78 sentences for each class, which was the size of the minority class. So in fear, there were 78 sentences to begin with. So I reduced all of the other emotion classes to 78 sentences. So the results, although the overall micro F1 score decreases, the results do show a big improvement for the two minority classes. So if we compare the imbalanced and the balanced corpus, the score for anger increases, the score for fear increases dramatically, but there is a slight reduction in the scores for joy and sadness, which were the majority classes. So these results show that hopefully with a bigger corpus and balanced classes, the classifier would actually work quite well, which is kind of evidenced by the increase in the scores for anger and fear. And this table just shows the misclassifications that came from the balanced corpus. So in most cases, the classifier has misclassified logically, so it's predicted sadness instead of anger. The illogical classifications are probably caused by the fact that it's a very small corpus and that there weren't enough representations of words to make accurate predictions. So overall, what does the research show? Well, if I go back to my research questions, can a hybrid machine learning method be used to predict emotions? The method does show promise. It achieved an accuracy score overall of 65%. So it does work in some cases, but the accuracy of the predictions was inhibited by the imbalanced classes and the size of the corpus. The second question, which is which emotions are relevant to the study of emotion. So there's evidence from analysis of the post that an expanded set of emotions might be relevant for work related to LGBTQ+ cancer forums, rather than the narrower set of emotions that are usually used in emotion detection and emotion prediction, which come from predominantly from Ekman's basic emotions. So loneliness and isolation is a common theme throughout the corpus and is an area of concern that's reiterated throughout the existing literature. So this might be an emotion that's important to consider in future research. And on the use of topic modeling, it provides an automated method of grouping the corpus into topics so that we can quickly get an idea of the themes that are present throughout the corpus. And this research didn't show a particular correlation between the emotion classes and the results of topic modeling, but a better correlation might be produced on a reduced set of emotions or with a balanced corpus. So implications from this research. So extracts from the corpus do point to the need for more training for healthcare providers, and that there's a need for more literature as well relating to the subpopulations within the LGBTQ+ community. The results show that the online community is a useful resource for support, so users find it very helpful to have access to it. And possible further research could include using emotion prediction to flag forum users who either might be at risk or who might need access to further information. And just to go on to what I learned from this, well, the first thing is that I used too many emotion classes. There was a lot of unused data in the emotion prediction task because I had to cut out basically 4 of the emotion classes that I used. I think the simplest explanation for that is that I got a bit carried away because it was my first kind of research project that I was doing independently. And in hindsight, I should really have only used the emotions that I would be able to get effective lexicons for. I've already discussed the variability and annotation standard from the MTurk annotators, so I'm not sure if I would use that method again in the future. And I've already discussed as well that the imbalanced classes and the small corpus played a big part in the accuracy of the classifier. In relation to this research, it wasn't only cancer patients that were on the forum, but it was also carers and friends and family, which in other research this might be a problem, but actually in this research it produced a lot of insightful data. So that was actually quite beneficial to the research. And lastly, the ethics of the project. I mean, there's a lot of research that's currently being conducted into online forums, and it takes the stance that it's ethical to record activities in a public place without consent, provided that individuals aren't identifiable. But it's difficult to know where the boundary is, and even when research like this is conducted for the best intentions, it's important to consider that there could be a dual use dilemma, and it is important to consider that the users feel safe in using an online space. And finally, the lessons that I learned from this, particularly for the programming. Sometimes I asked Google a question and it came up with irrelevant results, and if I changed the question 5 different times, it would eventually give me what I was looking for. So yeah, that was the main thing I learned, was just keep asking the same thing in different ways. The second thing I learned was that there are some programming bugs that just aren't going to be obvious, and it's just going to take hours or days to find what is wrong, and that's just a frustration. And finally, less is sometimes more. So particularly in relation to the emotion classes, I would say that that was an error that hopefully I won't make again. So that's the end. Thank you for listening and attending. And if anyone's got any questions, feel free to ask now, or if you want to drop me an email at a later date, my email is on the bottom of the screen.